In this video, I am going to explain linear programming problem by using graphical method. So before we go for the problem, let me explain the basic concept of linear programming problem. See, LP, that is linear programming, is a mathematical programming technique to optimize the performance. Generally in an organization, there are two major objectives. First one is minimization and second one is maximization. So minimization of what? Minimization of total cost of production, that is their main objective, and second important objective is maximization of their profit. So these are the major objective of any organization. Okay, so here in graphical method there are different models are there. Okay, so with the help of LPP graphical method you can able to find the optimum solution. In LPP we have different methods. For example, graphical method, simplex method, dual simplex method, big M method. So these are the different methods are available, but the graphical method is applicable only when we have only two variables. If we have more than two variable means the graphical method is not suitable. So here I am going to explain three different models of graphical method. The first one is maximization problem and second one is minimization problem. Okay, but in the first two methods we have two constraints. So this is the objective function subject to two constraints are given in the first problem. In the second problem also same thing, but the first one is maximization problem and second one for minimization problem. So I am going to explain two different models, maximization model and minimization model, and the third one is maximization, but here we have three constraints. In the above two problems we have only two constraints, but in the third problem we have three constraints. So constraints means three equations are there. Okay, so here I am going to explain three things. In the first video I am going to explain the first one. The remaining second and third we'll see in the separate video. Let us see the first problem. Say, solve the following LPP using graphical method. This is a problem. Okay, maximize Z is equal to 12x1 plus 16x2. This is the objective function of the problem. Subject to two constraints are given. First one, 10x1 plus 20x2 less than or equal to 120. This is the first constraint, and second constraint is 8x1 plus 8x2 less than or equal to 80. So now we have two constraints. Our objective function is maximization problem. Okay, you need to find the value for x1 and x2. The value should be greater than or equal to 0, which means positive value only. Greater than or equal to 0 means 0 or more than 0. So first step is just convert the first constant into an equation. So write the first one, 10x1 plus 20x2 is equal to 120. So this is the first equation. So now we have to find the value for x1, x2. We need 2 points to plot in the graph sheet. Okay, so first thing you need to take x1 as 0. See, when x1 is equal to 0, what is the value for x2? So when x1 is 0, what is the value for x2? Just apply this in the first equation. 10x1 is 0 plus 20x2 is equal to 120. 10 into 0 is 0. We have only 20x2. So 20x2 is equal to 120. So x2 is equal to 120 divided by 20 is equal to 6. So x2 value is 6. When x1 is 0, x2 will be 6. In the same way, now we have to consider x2 is equal to 0. Then what is the value for x1? When x2 is equal to 0, what is the value for x1? Just apply this in the same equation. 10x1 plus 20, x2 value is 0. No, put 0 here. 120. So 20 into 0 is 0. We have only 10x1. So 10x1 is equal to 120. x1 is equal to 120 divided by 10. So x1 is equal to 12. When x2 is equal to 0, x1 value will be 12. So now we have got 2 points. With this you can plot into the graph sheet. In order to draw a line, we need to have 2 points. Okay, first one is x1 0, x2 6. This is the first point. And second point is x1 12, x2 0. This axis x1 axis and this one is x2 axis. So plot the line. First one x1 0, x2 6, x1 0, x2 6, 0, 6, x1 0, x2 6. Second point x1 12, x2 0, x1 12, x2 0. So this is the point. x1 12, x2 0. We have got 2 points. Just join the 2 points to make a line. This line represents the first constraint. Now we have to find the second line. Okay, look at the problem. Look at the second constraint. 8x1 plus 8x2 less than or equal to 80. Second equation. 8x1 plus 8x2 is equal to 80. So second equation. In the same way, we need to find the value for x1 and x2. So in order to draw a line, we need to have 2 points. x1, x2. When x1 is 0, what is the value for x2? In the same way, when x2 is 0, what is the value for x1? When x1 is equal to 0, what is the value for x2? Okay, just apply this in the equation. 8x1, that is 8x1 plus 8x2 is equal to 80, no. So 8 into 0, x1 value is 0, no. Plus 8x2 is equal to 80. 8 into 0, 0. We have only 8x2. 8x2 is equal to 80. So x2 is equal to 80 divided by 8. So what is the value? 10. 10. In the same way, find the value for x1. When x2 is equal to 0, what is the value for x1? What is the equation? 8x1, no. So 8x1 plus 8x2 value is 0 is equal to 80. 8 into 0, 0. We have only 8x1. 8x1 is equal to 80. So x1 is equal to 80 divided by 8. So value is 10. So x1 is equal to 10. When x2 is equal to 0, x1 value will be 10. With this, now you can plot the second constraint. x1 0, x2 10. This point 0, 10. Second one x1 10, x2 0. x1 10, x2 0. Now join the 2 points. This line represents the second constraint. Now you need to find the feasible region. In order to find the feasible region, just see the 2 constraints, that is 2 equations. Just check whether it is less than or equal to or greater than or equal to, because based on that only you can able to find the feasible region. So look at the first constraint, less than or equal to. Second constraint also less than or equal to, which means you have to find the feasible region. The feasible region should be below the line which you have drawn in the graph sheet. So this line represents the first constraint and this line represents the second constraint. Okay, see, the shaded portion is the feasible region. Okay, so in order to find the feasible region, both the constraints are less than or equal to. So the feasible region should be below the 2 lines. So if we select this one, this will be under second constraint but above the first constraint. If we select this region, this will be under first region and above the second region. So these are the 2 regions which is not feasible. So this is the feasible region. Why? Because this particular shaded portion is below both the lines. We have 4 corners. This is the first corner, second corner, third corner, fourth corner. So these are the 4 corners in the feasible region. No, this will be A and this is B. This corner name is B. this is C, and this one is D. The closed polygon ABCD is the feasible region. Okay, so after finding the 4 points, so you have to find the value. What is the value for A? 0 and 0. X1 also 0, X2 also 0. What about B? B value is X1 10, X2 0. Look at the C point. X1 8, X2 2. X1 8, X2 2. Just see 8 and 2. Okay, the same way D. D value already is there. 0, 6. That is X1 is 0, X2 is 6. So we have got 4 values for 4 corners. That is after finding the feasible region. Now we need to substitute these values in the objective function. What is our objective function? So this is the objective function. No, that is maximization z is equal to 12x1 plus 16x2. So we have got 4 points. No, so we have x1 value, x2 value in each points. Okay, so now you need to substitute those values in this objective function in order to find the optimum point, that is optimum corner. So let us see how I am going to work out this. See, now I am going to substitute this value, that is A's value. X1 value 0, X2 value also 0. So now I am going to substitute this value in the objective function. See, this is the objective function. Maximization z is equal to 12x1 plus 16x2. So A's value 0, 0, no. So x1 0. 12, x1 value 0 plus 16, x2 value also 0. So what is the answer? 12 into 0, 0 plus 16 into 0, 0. So 0 plus 0, 0. Then in the same way we need to find the value for B, C and D also in order to find the optimum point. Look at the B's x1, x2 value 10, 0. x1 value 10, x2 value 0. So 12, x1 value 10 plus 16, x2 value 0. So 12 into 10, 120 plus 16 into 0, 0, 120. A, B is over. Now look at the C. X1 is 8, X2 is 2. For C, 12, X1 is 8 plus 16, X2 is 2. 12 into 8, 96 plus 16 into 2, 32. So 96 plus 32 is equal to 128. A, B, C's are over. Now look at the fourth one, D. D's value is, X1 value is 0, X2 value is 6. For D, 12, X1 value is 0 plus 16, X2 value is 6. Okay, so 12 into 0, 0 plus 16 into 6, 96. So 0 plus 96, 96. Now we have got the Z value for A, B, C, D. Since it is a maximization problem, we need to find the maximum point. So look at the 4 answers. Which one is highest value? 0, 120, 128, 96. So this is the highest maximum amount. See, the Z value is maximum in the corner point of C. The Z value is maximum for the corner point C. So this is the highest point. No, C is the highest point, optimum point. So X1 value is 8, X2 value is 2. Optimum Z is 128. Hope you all understand this concept. Thank you.